Hello and welcome. I'm Sonam Tenzin of Thare Electrical, and with me I have my friend Sonam Tashi. And today we will be doing practical on single phase half wave uncontrolled rectifier with motor load. And we will study the effect of freewheeling diode. And this is the circuit diagram for the single phase half wave uncontrolled rectifier with a freewheeling diode connected to a motor load. And basically, when it comes to a motor load, it is an inductor and a resistance connected in series. And here we have D2, which is a freewheeling diode. And freewheeling diode is normally a normal diode which is connected in parallel to the motor load, so that the output waveform of current and voltage are current is continuous, whereas for the voltage it makes the output more smooth. And there are two cases of operation within the single phase half wave uncontrolled rectifier. And here we have the waveform for the operation of the single phase half wave uncontrolled rectifier. And this is the source voltage Vs, and here we have resistance voltage and inductive voltage. And Vs is equals to IR plus LdI by dt. And this is the inductive voltage, whereas this is the voltage drop across the resistance. And during the negative half cycle, the current flows in this direction. During the negative half cycle, the flow of current is in this direction, and we see that D1 is reverse bias. As a result, there is no voltage registered at the output of the load. And at t is equal to 0, the direction of flow of the AC source is reversed. The direction is reversed, and the current flows from diode 1 and to the inductive load, inductive and a resistance load, which is the motor load, and it flows in the forward bias of a T1. And here at t is equal to 0, the source voltage rises, and until T1, the source voltage is greater than Vr. And from this we can say that Vn is equal to Vs minus Vr. And for time period from T0 to T1, source voltage Vx is greater than Vr. And from this we can understand that the current rises gradually until T1. And from T1 to T2, from T1 to T2, we see that Vx is less than Vr. As a result, the current starts to fall to 0, but since the nature of connected load is motor load, the current falls gradually, and when the supply voltage falls to 0, the current doesn't fall to 0. As a result, the diode T1 is still in the forward bias, and a negative voltage is being registered in the output across the motor load. And the effect of the freewheeling diode can be seen during the negative half cycle. During the negative half cycle, the circuit is disconnected. Circuit is similar to such that it is only this part of the circuit remains. And during the negative half cycle, since the energy is stored in the inductor, the inductor energy will dive D2 into forward bias. As a result, the amount of energy that is stored in the inductor is being released through the diode, which is then now short-circuited, and it will flow to the resistor and dissipate in the resistor. As a result, there will be a smooth waveform, output voltage waveform, as well as there is continuous current flow in the output of the motor. Now we will look into the output waveform of a single phase half wave uncontrolled rectifier with and without freewheeling diode. This is the waveform without freewheeling diode, whereas here we have the output waveform for single phase half wave uncontrolled rectifier with freewheeling diode. We have in the circuit we have given the input as a sinusoidal AC, and this is the input wave, and without freewheeling diode, the output of the motor load will be only registered in 180 degree. Since it is a single phase half wave uncontrolled rectifier, it will be output will be of 180 degree only in positive half cycle. But since there is no freewheeling diode and the nature of the load is inductive, we will observe output registered in the negative half cycle. Whereas for the freewheeling diode connected in parallel to the inductive motor load, we observe that the waveform is purely positive and half wave positive, whereas for the freewheeling diode connected in parallel, we will also observe that the current is continuous, which is due to the inductive energy stored in the inductor that drives the freewheeling diode into forward bias, and as a result there is continuous flow of current within the motor load.
Now I will be going on with the procedure. The aim of our experiment is to see the effects of freewheeling diode on a single phase half wave uncontrolled rectifier, and in order to do so we have already made the connection, and for this connection the live wire of the single phase power supply is connected to the anode of the diode, and from the cathode of the diode we have connected to the motor load, and the neutral of this motor load is connected directly from the power supply, and from motor node we take it to the power scope. It is connected to the power scope, and from the power scope we take it to the oscilloscope. And in order to run this experiment, we put on the 3-phase MCB from behind, and then we put on the single phase supply from here. Then we will get some wave from here.
Now that we have observed the waveform for single phase half wave uncontrolled rectifier, we observe that there is a negative voltage registered in the output waveform, and this is because during the positive half cycle the diode conducts, whereas for the negative half cycle there is no conduction by the diode, and for the supply source it is a sinusoidal waveform, and since the nature of the load is inductive, which is a motor load, and as a result the current rises gradually as well as it decreases gradually, and for the voltage it is sinusoidal and it rises to its maximum, and the current will also reach to its maximum when the supply voltage is at its maximum. And when the supply voltage is 0, the current doesn't fall to 0. As a result, the diode will keep on conducting even for the negative half cycle, and we see that this is the zero baseline, whereas for the output voltage we see that there is some voltage being registered in the negative half cycle, and this at time t here we see that the current is at is 0, and as a result there is a negative voltage registered in the output of the RL load.
Now we will see the effects of freewheeling diode on a single phase half wave uncontrolled rectifier with motor load. The overall connection almost remains same, just that we add one freewheeling diode parallel to the motor load. In order to do so, we take cathode of this diode D1 to the cathode of this diode D2, and from this anode of this diode D2 we take it to the neutral of the power supply. And precaution must be taken so that there is no short circuiting in this circuit. If in case we connect the cathode of this diode D1 to the anode of this diode D2, and from cathode of this diode D2 we take it to the neutral of the power supply, there will be formation of huge current which may lead to the damaging of the equipment. Now that the connections are all done, we would like to see the waveform, output waveform.
This is the observed output waveform for the single phase half wave uncontrolled rectifier with freewheeling diode, and here we observe that there is no negative output voltage registered, and this is the use of freewheeling diode. And for the freewheeling diode, when the supply voltage is 0, the nature of load will cause the current to degrade slowly, which will drive the diode in forward bias. But when the freewheeling diode is connected, the freewheeling diode will act as a forward bias, and it will be short circuited, and as a result all the current that is stored in the inductive load will be passed to the freewheeling diode, and the output waveform will be much more smooth.